understand piecewise functions, they understand linear equations, but then I throw them a problem like this and they get utterly confused. So let's call this one h of x, and let's bring in some different functions, right? Because the cool thing about piecewise functions is we're not limited to just linear equations. We can really use any type of function that we want to as part of our rules. So in this one, where we're going to have x plus 1, and then x is going to be greater than 1. Okay. So we have a radical and we have a quadratic. Now, in this case, I am going to do a couple extra steps just to make sure that we are on the same page of how to graph these. So 1 minus x, remember when we have transformations, especially with our b, we want to make sure we rewrite that to be positive. So I'm going to rewrite this as a negative x plus 1. And then remember, you have to factor out that negative. So y equals a negative times x plus 1. Okay, so that's very, very important, because if I was to graph what is y equals the square root of x on, students just constantly forget what that graph looks like. It looks something like this. But now I have a plus 1. I'm sorry, I forgot to factor out the negative. Mr. McLogan, come on, don't do that to yourself. When you factor out a negative, that becomes a negative 1, right? Factor out the negative from both terms. So remember transformations, this is going to be a shift 1 to the right, but then also we have this reflection, but we're going to do the reflection first. So I'm going to reflect it across the y-axis because it's inside the function. So it's a reflection about the y-axis, and then shifted 1 unit to right. So this graph is actually going to look something like this. It's going to be shifted 1 unit to the right, and then it's going to go like this. It's going to go in that direction. Okay, so that is what y equals a square root of negative x minus 1. Okay, now let's go and look at the quadratic graph, which, hopefully, again, at this point, you guys should be semi-familiar with, the quadratics. So I have y equals a negative x minus 1 quantity squared plus 1. Okay, so hopefully remembering quadratics, we identify the vertex, which is the opposite of the inside, just like we did over here. So that's a 1, 1. We have a negative on the outside of the function. So instead of a reflection about the y-axis, like we did up here, because that was a negative on the inside. When you have a negative on the inside of the function, that reflects about the y-axis. When you have a negative on the outside of the function, that reflects about the x-axis. So again, this graph is going to look, I'm not going to follow my lines here, but this graph is at my new x-intercept, so like 1 over 1, but then it's going to be facing down. Okay, now again, remember, we cannot put these two graphs on top of each other, right? Because they would intercept each other. They would fail the vertical line test, right? They would fail the vertical line test. So that's why we have to go back to these restrictions. Okay, so I'm actually going to copy this and I'm just going to repost it again so we can see what we have here. So let's see. Let's do that again. All right, so let's go ahead and now put them on the same axes here. I don't want to use red. Okay, so I'll have this here. And now we know, remember that graph was shifted 1 unit to the right. Okay, and its x is less than 1. Well, here's obviously 1, so that's good. So it's going to be an open circle. And it's going to look something like that, right? And then this one, if you remember, was over 1 up 1, right? It's over 1 up 1, and its x is greater than 0. So from there, and just remember this graph has this form, right? So remember the graph is going down and to the right. So then the graph is going to look something like that.